Hi, John the Drivability Guy here. Today I want to do part one of a three-part series on using the Picoscope. My plan for the three-part series is going to be, in part one, getting you familiar with how to navigate through the software of the Picoscope. Parts 2 and 3 will actually be hooking up to live vehicles and using it to perform various diagnostic tests on these live vehicles. So, a couple nice things about the Pico software is no matter what version of the Picoscope you bought, you got the actual blue box. So whether it's a 2-channel, 4-channel, 8-channel, whatever the case happens to be, you definitely got the actual one-to-one wires that they call them, and you definitely got the actual 10-to-1 adapter. So a little bit about this is if we were going to be hooking up to, say, primary ignition voltage, we wouldn't want to damage the scope, so we'd have to put this in series with our one-to-one leads. The Pico website will actually have this whole package available for you. This would be what they call their starter package. These packages go all the way up into the several $1,000s range, where it will come with a whole bunch of more accessories, which I'll kind of show you throughout the rest of this video here in part one. The Pico website, while we're on the topic of that, is a very nice website because if you happen to have the Picoscope already, great, go ahead and turn it on your laptop and you can follow along with us here throughout the rest of this presentation. But if you don't happen to have it, maybe you're considering purchasing it in the future, they will allow you to download for free a full version of their software. So obviously you're not going to be able to use it on a car without actually having the actual scope. But it allows you to learn how to navigate the tool and get the full experience to make an educated decision on whether or not this is the right tool for you. Also, while you're on the website, you'll notice that they have a full-fledged actual Pico waveform database. So a lot of times people talk about the free databases on IATN and diagnostic.net, and nobody really knows about the known good waveform database that Pico offers us for free as well. And again, you don't have to have the actual scope to actually take advantage of that website. So you could go there, even if you got some other manufacturer's lab scope, and you can go in there and look for a known good waveform for, say, a cam crank sensor correlation waveform on a Subaru or whatever the case happens to be. So without any more further ado, I'd like to kind of get started here. What I've got is I've just went ahead, and obviously I assume you've also already installed the software. I opened up the actual Pico Automotive software. You're going to get this screen. And on this screen you'll notice that it comes up anytime you have this screen turn on. You'll see that the default is it's going to have the divisions displayed in the background. The divisions are the little squares that you see on your screen. So anytime we're dealing with an actual vertical rise, that's going to be a scope terminology term for that is called amplitude. That's going to be a certain level of voltage. And anytime that we go a horizontal across the screen, that's going to represent time. So as we go through this, we can actually see how we're going to manipulate these settings and how we can actually make the scope think instead of measuring voltage over time, we're measuring current or amperage over time, whatever the case happens to be. So the scope comes up like this, and I want to go ahead and just start off very basic. What I'm going to do is I'm going to take my one-to-one lead, and I happen to have the 4-channel version of the scope here. So I'll plug this right into channel A. Notice that as soon as I do that, we get something that we call aliasing in the scope terminology world here. What we're actually picking up is the interference from the overhead lights and stuff right now. And what I'm going to do to kind of save a little bit of time is I put together just a makeshift little demo board here. I've got just a couple different types of automotive signals on here. I've got a digital square wave off a map sensor here, a Ford map baro sensor. I've got a knock sensor, which would be like an AC style signal. I also have a throttle position sensor over here, which is just going to be a DC type of signal. And then I actually bought a couple little demo boards. One is from Fluke, one is from Snap-on. That gives us a couple other choices here. You could look at some secondary ignition patterns, some fuel injectors patterns and stuff like that. So even if you don't happen to have this little homemade thing that I did here, You know, Snap-on and Fluke and other manufacturers do sell all these little makeshift demo boards. They come in all different shapes and sizes. So here's two from Snap-on that you could actually purchase. Here's a nice one that's kind of shaped like a card that has all different types of signals on there. So it's something that if you decided you wanted to purchase it in the future, go right ahead and purchase it. But for what we want to do for our demonstration purposes today is I'm just going to go ahead, I'm going to power up my demo board, and I'm just going to clamp on to the signal and the ground wire. Notice as soon as I did that, this is for the forward map or baro sensor, as soon as I did that, because the scope is all the time automatically sampling, up in the upper left hand corner we see the auto button there, it's going to try to display a picture for us. So it gives us the waveform going across the screen, which will get us in the ballpark, I like to say. And what I mean by that is I don't have to necessarily know that, hey, this is going to be a 0 to 5 volt signal. I don't happen to have to know what the time frame to set my scope up is. It's going to acquire the signal for me. But for diagnostic purposes, and this isn't a very sexy sensor here, this is just going to create this waveform. So this regular square wave type of a waveform. So what I want to do though is if I wanted to actually zoom in on a section of this and actually stabilize this pattern. Again, this particular sensor, not that big of a deal on. But as we go through our presentation here, you'll see as we get into more complex type of sensors, like in the ignition systems and stuff along those lines, it becomes vitally important to actually kind of stabilize that pattern. So what I'm going to do is I'm just going to show you guys how to do a couple quick adjustments here. So in the upper left-hand corner, we got our channel A, which will go ahead and tell us, if I click on that, it would bring up a drop-down menu that's going to allow us to choose different types of cables that I might have hooked up to my channel 1. So right now, we've just got the 1-to-1 cable, which is the default, but let's say I wanted to go ahead and try to current ramp an ignition coil or something along those lines, I would have to go to that channel A there, or if I was actually having the current probe hooked up to channel B or whatever the case happens to be, and I have to tell it what type of weight, what type of clamp I'm actually putting on this type of signal here. But for right now, it's just 1-to-1, so I don't have to change anything here, but I'll kind of scroll down so you can kind of see the differences of what they offer. So my 1-to-1 probe, my 10-to-1 probe, a 20-to-1 probe, a 100-to-1 probe, my low amp and high amp current clamps here, different types of pressure transducers, and we'll be covering this throughout the 3-part series, all the different types of actual leads that you're going to possibly buy either initially when you purchase the kit, or maybe you're adding on to your collection of Pico leads as time goes on here. So it kind of gives us an overall view of what kind of leads are available. When I go over here, if I just go to, since it's channel A, if I just go to the drop down button where it says auto, this is going to bring up my voltage scales. So notice right now I'm running at about 4.5 volts or so. If I go ahead and just change this to, say, a 2 volt per division, if I do that, notice that right away I'm now over the channel range here. It's now off the screen. So I don't want to possibly go and set this up, but again, I can't hurt the scope. The only way I could really hurt the scope is if I'm sampling a voltage that is far exceeding the capability of the scope, which is why the 10-to-1 transducers and also the 20-to-1s and 100-to-1s become important. And unless you're dealing with some like ignition systems or maybe some some gasoline direct injection, GDI type of waveforms for injectors or something like that, you're really not going to have a tendency to ever have a chance of damaging the actual scope here. So there is no wrong way to set your scope up, is what we're trying to say. So notice that I still have the same voltage present, I just had it so that it was off the screen at the time. Now if I wanted to change the actual time base, I'm going to come up to this one here, and I know it's a little confusing at first because Pico has 2 different time bases right next to each other. We're going to talk about the one on the far left first. So right now we're at 5 milliseconds per division, which means from the distance from the one side of a square to the next takes a total of 5 milliseconds. If I go ahead and hit that drop down menu here, here's my scales to adjust the actual time base. So again, I'm just going to select 20 milliseconds just as a rule of thumb here. The actual pattern that the sensor is putting out has not changed at all, but notice I have it repeating itself many more times going across the screen because I now said that each one of these little squares represented 20 milliseconds of time instead of 5 milliseconds of time. So there's a lot more time that we're sampling across the screen. Now, it's a little bit ahead of ourselves. We'll come back and visit this, but this other little time-based box up here, that is actually geared towards your buffer setting. And we'll explain that in more detail when we go over the buffer, the recording feature of the actual Picoscope. At default of 1 millisecond there, that's actually a pretty good sampling rate, the actual 1 mega sample rate here. So what I'm going to do is I'm going to go back and change my time base. I don't want to see that many of them on the screen at once. So I'm going to go ahead and just get it back to how it was initially set up. And now the most important thing to set up on a scope, in my opinion, I'm going to move this out of the way here so the camera can pick it up, is at the bottom of the screen we have our trigger settings. So I'm going to go over here, and right now the trigger is defaulted into none. And what trigger means is your scope is automatically sampling, but it needs some input as to when to start drawing its picture across the screen. So I have to set the trigger level and also the trigger slope. So those are the two fancy words there. But notice what I do. As soon as I go ahead and take it off the none and just put it on auto, this little yellow diamond appears on my screen, and the waveform still kind of appears to be walking back and forth, not nearly as bad, but if I just grab this diamond and just raise it up a little bit, notice what that did to our waveform. It locked it 100% steady on our screen. So why would I ever want to actually lock the pattern like that? Well, for diagnostic purposes, let's say I'm current ramping an ignition coil or something, and maybe there's an ignition misfire that's occurring, and I just want to see one section of that waveform, I'm going to want to have my trigger set up properly. So I went ahead and just showed you on a very basic type of waveform here, which is just the square wave from this old map sensor, just to show you what the advantage of actually locking the waveform like that. Now, I always tell people that it is possible for us to adjust trigger incorrectly, which would then cause us to possibly miss the pattern 100%. So if I took my trigger level and I adjusted it way up to like the 5-volt range, notice that my sensor never gets that high. So I would lose the pattern 100%. So I don't want to have it adjusted when I'm trying to acquire the signal. So I always leave it when I hook my leads up on the none feature at the bottom of the screen. Once I get the pattern on the screen, then I go ahead and put it in auto, and now I can go ahead and adjust my trigger. I can actually take this yellow diamond, I can actually go way up here, I could go anywhere on the scope screen. If I go to the left or right, that's known as trigger offset. So right now it's offset at right in the dead center of the screen. I could go on a negative offset or a positive offset of this and actually come up with, you know, the way how the scope is set up right now, up to 25 degrees negative offset or 25 degrees positive offset over here. So this is how I'd actually pull up and use my trigger setting. Now when I'm actually using the scope here, we have some other features that we have where I can grab the side of the screen and I can pull up the actual cursor. And if I pulled up the cursor and just brought it down, it's represented by this dotted line here, and just brought it down, it's going to tell me that, hey, this sensor is putting out a total of 4.617 volts. So the amplitude from 0 volts all the way to the top is 4.6, a little bit more than 4.5 volts. I also have the actual cursor at the bottom of the screen, and I could grab this, and this is my vertical overall measurement here, which is going to allow me to measure the time. So I can pull this over and I can pull it all the way over to the side of the screen. However much of the waveform I wanted to sample and measure here, I can actually pull this up and it would tell me, you know, hey, this one part of the waveform that starts in the middle and goes over to here took a total of 3.165 milliseconds. So I could actually do that, and in this particular case with this very basic sensor, not that important to use something like this. But let's say we were measuring cam crank degrees of offset and we wanted to see if the engine jumped time, those cursors would become very important here. So again, I'm just showing you some basic navigational features here. I just hit the X button to get rid of the cursors. One other thing I want to show you real quick while we're still on this screen before we get too much further, I could go ahead and zoom in or zoom out on any part of this waveform. So if I come up to the top part of the screen, I got some magnifying glasses here. Obviously the plus one is what we're going to select if we want to zoom in. Now anything that I draw with my mouse, that section of the waveform is going to get zoomed in. So if I just go ahead and do that, notice that I didn't really change any of the settings. I just made it so it was a lot easier to see that. Here's my actual waveform still displayed in the bottom right hand corner here. So I could keep zooming in if there was some hash marks going on there or whatever the case happens to be, I could just keep zooming in on that to really get a detailed picture. Or if I say, okay, we'll talk more about it when we get something a little bit more intriguing on our screen, I'll just hit the X button over there to zoom back out. So all of this was done with just one channel setting here. So I just have one lead plugged in, that's what the individual channels are. I'm hooked up to just this one sensor over there. Now, a couple more things I wanted to show you guys. A lot of times people will have a question of, hey, I'm trying to hook up 2 channels, 4 channels, 8 channels, whatever the case happens to be. But when I do that, my waveforms, they don't jive right. So what do I mean by that? Well, they don't really, I can't get the detail that I'm after on them. And what the reason being is all lab scopes on the market, with the exception of one, can only sample that one time base. So what does that mean? I could have 2 channels all the way up to 100 channels if they ever made a scope like that. It only has a refresh and a baud rate of sampling at one given specification. So if you set your time base up here, you're going to get a really good picture of one of the channels. But if you got 2 sensors that don't share the same type of speed, so right now we're going to use a map sensor and a throttle position sensor. The throttle position sensor is going to be a much slower sensor. So if I have 2 of them hooked up at the same time, I'll have a nice looking picture on one, but the second one is not going to have a whole lot of diagnostic value to it. So I'll explain a little bit more about this after I show you what I'm referring to. To get channel 2 hooked up, I plugged my channel 2, my channel B leads in. I've already got hooked up to the board. I have to come over to my scope screen, and I have to actually tell it that I just did that, and I want it to sample something else. So if I go over to channel B over here, again, I'm just using my 1-to-1 leads right now, so that's going to be the default. But if I had to change it, if I was hooking up a current probe or something, again, just like we said before, if I click on that letter, this would be my drop-down box of all my choices of the different types of leads that I'd have hooked up. But we're going to leave it on the channel, the 1-to-1 type of lead here. I'm going to go to the box that says off, and I could hook it up to auto. I could hook it up to any one of these things. So if I did auto, you'll notice that, hey, here's my red lead now. Notice that it's channel B, and the scope, I'm not going to really get real involved with this because it's not really that important. But if I didn't like red for whatever reason, I could make that a handful of different colors. I left it as a default of my channel A is blue because that's the blue lead that says channel A. My channel B is defaulted to red because that's exactly what the lead color is. My channel C is defaulted to green, and my channel D is defaulted to yellow because that's how Pico's got their color schemes going across the screen here. But again, if you didn't like red for whatever reason, you do have the ability to change that. Not that important though. So Notice that once I turn channel B on, it's asking me what type of voltage or what type of signal am I sampling here. It's defaulted to DC right now because DC coupling, because that's what the auto sensed when I had these things hooked up. Now, if I were to actually operate this waveform right now, notice what's happening. It's going right off the top of the screen, and I'm not seeing my typical TPS sensor sweep here. So I would have to make some changes. So in order to do that, I'm going to change the time base so it actually kind of matches a better looking picture for throttle position sensor. So what I'm going to do is I'm going to come over here and I'm going to select, say, 20 milliseconds per division. Now when I do this, I'm getting a much better looking pattern, but it's still out of range going off the top of the screen. So I got to change the voltage scale of my actual channel B lead here, and I'm going to take it off auto, and I'm going to say, let's go with 1 volt per division here. And now when I do this, I'm still a little bit too high on that. I'm going to go ahead and change it one more time for us, and I'm going to go, let's go with 5, right? Plus or minus 5 volts. Now when I do this, I'm going to get a much more, depending on how fast I actually open and close this throttle position sensor, this is what the car's computer is seeing every time you step on the gas pedal, right? So when I do that over and over again, I would get the pattern that I'd expect to see. And I'm even going to change the time base a little bit more, and I'm going to go to 200 milliseconds to really get my point across. And my red thing is really looking exactly like what I want it to look like. Now, I know it's a little bit hard to see. Anytime I want to differentiate these patterns, because they're both defaulting, and if I had all 4 channels hooked up, they'd all be trying to line up to the 0 volt line going in the middle of my screen here. If I just grab the actual channel that I want to move here, on the right hand side I'm going to move channel B, I'm just pulling that waveform down so I can differentiate and get my patterns 100%. Now obviously, if I wanted to go ahead and say, okay, in real world applications, what could this possibly be used for? So let me go ahead, what I'm going to do is I'm going to freeze the pattern for us. And to do that, in the bottom left hand corner, you're going to see a red square. And I'm just going to get a couple TPS waveforms going across the screen, and I'm going to freeze the pattern so it kind of locks in place. Let's say real world scenario, you would never really find a need to lock or to have the TPS and map sensor and all this stuff hooked up and lock it all on the screen at the same time. But let's say in the real world, the customer brings in the vehicle and the vehicle has got a complaint of, hey, I'm just driving down the road and it cuts out. It doesn't do it all the time, only does it sometimes. So it's an intermittent cutout type of complaint. And you say to yourself, well, I'm going to take it for a drive and it seems to run okay. But when it cuts out, you got to have a pretty good idea of what could cause this vehicle to cut out. So I would maybe hook my 4 channels up to, say, the crankshaft position sensor or the RPM sensor, because obviously if it loses that signal, the car's not going to go anywhere. I'd hook it up to, say, the fuel pump circuit, because obviously if you lose fuel pressure, that could cause the car to cut out. And maybe I'd hook it up to the ignition system. So those 3 areas is what I'd probably start with. Now all 3 of those areas would give me a waveform that looks something similar like this in the retrospect of those 3 different types of signals are not anywhere near the same sampling rate. So everybody puts a whole bunch of detail about this and they say, hey, there is one scope on the market, which is kind of an expensive scope, but there's one scope on the market that has 2 sampling rates, but I say you don't need it. The reason why I say you don't need it is, remember, even if I saw I had a problem in this blue section of the waveform, remember that was supposed to just be a square wave, but let's say I thought I saw the glitch happen right there at the point of the stall. Remember, in the zoom feature, I have the zoom. If I just go ahead and sample that one section, I can pull up whatever I wanted to see. So let's say instead of a map sensor, let's say that was the crankshaft position sensor, and I thought, hey, wait a minute, when the car stalled, you know, the Pico is going to lock the pattern on the screen. Also, it'll be in the buffer, which we haven't talked about yet. but I could just go back, even if it's all bunched up, even if the waveform was all bunched up, I could take that zoom feature and I could just zero in on that one feature, that one section of the waveform. So don't get hung up on the whole time-based setups here. It's all going to give you the same diagnostic information that you want to acquire here. And to get the pattern live again in the bottom left-hand corner, if I hit the green arrow, that's going to give me a live signal again. Now, one of the other things I wanted to talk about, which we haven't talked about yet, just to kind of make life easy, I'm going to take my channel B leads off here. We talked about setting up voltage scales, trigger, time base, stuff along those lines. I'm going to turn channel B back off because, you know, right now it's just going to add a little bit of confusion for us. So I just have channel A turned on right now. I want to talk about coupling. So the two signals we saw so far were both DC type of signals. I have this actual knock sensor on the board, which is a piezoelectric crystal, as you guys are all well aware of. That's actually going to be an AC type of signal. Now, setting up a knock sensor voltage pattern, I always tell people there is no right setup for that, because the louder the noise is, the bigger that waveform is going to get. So if I just take something and lightly tap on the box here, that's your AC type of signal. So I'm going to do that again, and I'm actually going to freeze the pattern so that you guys can actually see it on the screen. And obviously if I knocked a little bit harder, that pattern, the amplitude, the height of that would get larger and larger. And again, when we do the actual hands-on parts on the cars, you know, we'll take the time to explain, you know, what the whole purpose of the knock sensor on a vehicle is and all that kind of stuff. Right now, our main focus is just getting everybody familiar with how to navigate and set up the actual scope. So one of the things I want to talk about next is, notice that I keep referring to this terminology called a buffer, which is actually the movie that it's constantly taking. So your buffer, the tool comes with a 1 million sampling rate set up as the buffer. You could change that if you wanted to, but from experience, this is where I would highly recommend that you leave that. Because what happens is, when we're actually recording a pattern here, if I change that buffer enough, if I change this setting enough, my waveforms start to have a very weird appearance to them. So in the second part of this training series, I'll actually change that setting there and show you, say like on a fuel injector, how if I have that setting that is skewed way too far out from where it is right now, I would possibly think I have a bad fuel injector, when in all reality I don't. So I kind of would highly recommend that you leave the buffer where it is. But I've got the pattern stopped on the screen right now. I didn't fill up the buffer here, so it's only got the 8 screens going across. So I could go through and just go negative, 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 and then you see from the different times that I was knocking with the little adapter here, obviously I was knocking harder at this time here. So if my complaint was, hey, this thing cuts out on me at times or whatever, I don't necessarily have to be watching the pattern. I could just go through the movie or the buffer or the scope, which is a pretty powerful buffer, and actually find the point of the stall out or the point of whatever it was the customer's complaining about. So we've talked about the actual movie features, the cursors on how to measure the voltage or whatever the case happens to be. We talked about different types of automotive signals here. Let's talk a little bit about changing a probe selection. And again, in the second and third parts of the videos, we'll be using pressure transducers, current probes, and everything else. But just so that you guys kind of have an idea in this first section of the video here, when you go and purchase your actual current probes, a lot of times you're going to have a choice of either a high amp or low amp current probe.
Okay, you're good again.
Okay, so when you purchase your current probes, obviously when we're sampling electricity, this goes back to electricity 101, anytime we flow electricity through a wire, we create a magnetic field. And these current probes are just sampling that magnetic field. So they come in 2 different varieties, a low amp and a high amp. Obviously the low amp has the smaller orifice here. The high amp has the much larger orifice. So pretty much the high amp ones go all the way up to, into the 1,000 of amps that you're going to be measuring. The one that comes with the Picoscope here is a 600 amp high amp current probe. So this would be great for, starter draw tests and stuff along those lines, maybe some charging system tests, but you'll get a lot more mileage for diagnostic tests out of the low amp current probe. This is the one that you always hear and read about in the trade magazines, where people are current ramping ignition coils, fuel injectors, fuel pumps, headlight circuits, whatever the case happens to be. Anything that has electricity, you could current ramp. So what I'm going to do is I'm just going to go ahead and I'm going to unplug my channel 1 leads here. And if I wanted to change, it doesn't necessarily have to be a current probe that you're going to be messing with here. But if I wanted to change my input lead, we'll use a current probe as an example. I'm just going to plug that into channel A. And I'm going to go up on my screen over here to channel A that we've talked about. And I'm going to tell it that I no longer have a 1-to-1 probe. I now have a current probe. So this here says it's a 60 amp current probe. And I'm going to have... Okay, so I'm going to go ahead and I'm going to clamp around the red wire. The benefit to clamping around the red wire is I can actually see all the individual coils in this coil pack assembly. If I clamped around any one of the 3 yellow wires, I would only see 2 coils firing here. So what I did is I have this set up. I'm going to do a couple things real quick with my current probe. One thing I should mention to you guys, that the current probe has a direction of current flow. So I could either put it on like this, and I can get a pattern. I'm going to change the time base a little bit so I don't get quite as many of those going across the screen. So I can either get a pattern that has an appearance to kind of have the waveform going in the upward motion here. And I'm going to go ahead and change this to, I'm going to try to just get most of the pattern on the screen. So since this is just a demo board, I kind of got to experiment a little bit here with how I'm going to set up my actual scales. But before I get too far ahead of myself, let me show you what it would look like if I actually reverse the current probe. Notice that my waveform actually has a tendency to go exact upside down to one another. So if I go back to the auto setup here, right now I've got the actual pattern going in this direction. I'm going to flip this around. Notice what happens is the pattern has a tendency to want to go right upside down. So what do I mean by that? Notice anything that's from here going down is reading negative. Anything from here going up is actually reading positive. So I can actually just flip my tool around here, get the pattern on the screen. I've got about 5.5, maybe a little bit higher amperage coming out of those coil packs. Now this is where I was saying at the beginning of this presentation where trigger would become very important. So what I'm going to do is I'm going to change this time base a little bit more. I'm going to go to, let's say, 5 milliseconds per division. And notice that what we've got going on is the pattern appears to be dancing across the screen. The 2 most important parts of a current ramp of an ignition coil are right where it turns on and also right where it turns off. So I'm going to take my trigger and I'm going to go ahead and lock this pattern down, and I'm going to just bring this trigger level up a little bit to stabilize the pattern. Notice when I do that, it kind of locks it on the screen, and I'm going to zero in on that with my magnifying glass. And right here, this resistance to current flow is your first indication as to whether or not you have a shorted ignition coil. So in diagnostic purposes, I'd be very intrigued by looking at this section of the waveform, which is something we never would have been able to see that clarity if we didn't adjust the trigger level. And also the second part of this is anything that's happening over here is all the primary circuit. So if I saw a problem anywhere until the falling edge of the waveform, if I saw a problem with this section of the waveform, I would know my problem is either in the ignition coil, maybe the ignition module, something along those lines. Anything that happens after the falling edge is going to be a representation that I've got a secondary ignition problem, such as a spark plug wire, maybe a coil is arcing, if it's coil over plug, arcing inside of the valve cover or whatever, maybe a bad spark plug. So if I wanted to zero in on this section of the waveform, again, I can just move this box out of the way, and I'd be looking for a whole bunch of crazy hash marks right in this general area over here. If I saw that this was all loaded up and kind of looked like a hairy beard going across my screen, I would know that I'd have an indication that I got a secondary ignition problem. So for today's purposes of just getting you a generalized idea on how to set up your scope and how to navigate through the different screens here, and hopefully you were following along with your version of the scope, or even if you just downloaded the software, I feel that this will help you get a better understanding of when you go to hook up onto a vehicle, you being able to start using your scope to make money. Some of the other types of probes that we're going to be talking about in part 2s and 3s of these different types of videos that we have here are all the different types of probes that are available. So everything from the little paddle type of probes that they sell on the market, maybe your scope came with it, to the actual secondary type of cabling that they have, whether it be a capacitor or a trigger style thing. Also different types of pressure transducers. These are the types of things we're going to be using in parts 2 and part 3 of these various videos here. So for the time that we spend here together, I hope you guys found it intriguing and beneficial, and I look forward to seeing you guys in parts 2 and part 3 of this video. Thank you for your time.